Hello and welcome to Circuit Analysis Level 1. First question. We just want the current in this circuit and we know the voltage across this resistor. That's 3.4 millivolts on one side and 1.4 millivolts on the other side, and we know the value of the resistance, therefore that must be the current. Easy. They're not all that easy. Okay, that's a little bit more interesting. We need to know how much power is dissipated in the resistor. And we know the voltage across the resistor, bearing in mind this is a perfect ammeter. Perfect ammeters have no resistance, which means there is no voltage drop across a perfect ammeter. We know the voltage on this side is 3.2 millivolts, so the voltage on this side must be 3.2 millivolts as well. That means that the voltage across the resistor is 3.2 milli and the value of the resistance is 30k, so we can work out the power using the formula that power equals V squared over R. That would be 3.2 milli squared divided by 30k. Fine. Next. What current would the ammeter read? Again, not too bad. We have to work out the voltage across this resistor. There is no ground in this circuit, so we are free to define any point we like as being the ground point. Let's pick that point there, because that's the negative terminal of both of the voltage sources. That means this point here is at 6 volts. We'd get there going up through a 6 volt voltage source. And this point here is at 21 volts. We get there going up through a 21 volt voltage source. So the voltage across this resistor would be 21 divided by 6 volts. Therefore the current through would be 56k. This is the higher voltage than this, so the current would be flowing this way, which is in the opposite direction to the arrow on the ammeter. So the ammeter would read a negative current. We have to multiply by -1. Okay, next. Now, what current would this ammeter read? Again, nowhere in this circuit is defined as being 0 volts, which means we are free to choose. Let's choose that point there. We know the voltage across an ammeter is 0, so we know the voltage across this resistor. And we know the value of the resistance, so we can work out the current through this resistor, and it would be going this way from top to bottom, and the current through that resistor would be 8.4 millivolts divided by 91. And X now is the current going down through here. Well, if we know the current going down through here, that would be the current coming along through here. That must be equal to 65 microamps plus the unknown current. In other words, the unknown current is the current we've just worked out minus 65 microamps. So we could just say X minus 65 microamps. Right. We've done one like that before. Here's another slightly different one. Again, no ground defined, so let's pick this point here along the bottom as being ground. The voltage across this resistor will be 250 microvolts. So the current down through the resistor must be 250 microvolts divided by 5k1. And we know the current going down through this resistor must be the current going this way, 40 nanoamps, plus the current going this way, whatever is measured by the ammeter. So the ammeter current is whatever comes down through here, minus 40 nanoamps. So that's X minus 40 nanoamps, and so on. Hopefully you've got the idea by now. They do get slightly harder later on.